Okay, in this video we're going to talk about series and parallel circuits. So the first type of circuit is called a series circuit. And basically what we have is a battery or a source of potential difference. We have basically represented by two parallel plates, one positive, one negative. And that source of potential difference creates a current. Remember, current is the flow of positive charges. So positive charges coming from the positive plate, traveling around this circuit, traveling through each resistor, and eventually coming back to the negative plate. So we're gaining potential difference here, and then traveling around and losing potential difference, giving up energy in each resistor. But what you can see is that in a series circuit, there's only one path for the current to take. So the current in this resistor is the same as the current in this resistor, and it's the same as the current in the battery, right? There's only one path for the current to take. Now, if I was trying to determine the total resistance of these two resistors, let's give them a value of 2 ohms and 10 ohms, I can find that total resistance because it's the sum of all of the individual resistors. So I just find R1 plus R2 plus R3 if there was a third one, plus however many resistors I have. I'm just going to sum the total resistance. So in this series, the circuit series, or series circuit, sorry, we can see that I have a total resistance of 12 volts. Okay. So when adding up resistors connected in series, I just add the individual values together to get the total resistance. In a different type of circuit, which we're going to call parallel, what we have is again our potential difference, our battery, creating an electrical current flowing in the circuit. So we have a total current coming through this circuit. However, when it gets to this point here, the current splits. Not all of the current goes down each path. So I have I1 coming through this resistor and I2 coming through this resistor. Eventually, the two currents do meet up again at this end of the junction, and we have the total current coming back to the battery. But only some of the current passes through this resistor, and the rest of the current goes through this one. So again, if they are 2 ohm resistors and 10 ohm resistors, we can determine the total resistance of these two resistors because we know the relationship. In this case, because I'm creating multiple paths, I'm actually reducing the total resistance. So what I find is 1 over the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. There can again be as many resistors as you want, but you find the total resistance by finding the sum of the 1 over each individual resistor. So 1 over 2 plus 1 over 10. And that would give me here a total resistance of 1.67 ohms. It's 1.666 repeating, so rounding up to 1.67 ohms of total resistance. And what you can see is the total resistance is less than the individual resistors themselves. And again, that's because I've created multiple paths for the current to take. That's the definition of a parallel circuit. There are multiple paths for the current. So by creating more paths for the current to take, I actually end up reducing the resistance of the circuit. Again, think of it as a bathtub full of water. If you only have one drain in your bathtub, there's only one path for the current to take. You only get a certain amount of current. But if you start drilling more holes in the bathtub, you're creating more paths for the current, and you get more current coming from the battery or coming out of the bathtub. So what you've done in essence is reduced the overall resistance and allowed more current to flow. Okay, so that's parallel circuits when we have resistors connected in parallel. Now we can also connect voltages in series and parallel. So here again I have two batteries connected in series. So here's one battery, here's the second battery. If each of these batteries is, let's say, a AA battery, so it's 1.5 volts, the current that's flowing through this circuit passes through both batteries. So each coulomb of charge gains 1.5 volts when it passes through this battery. It gains another 1.5 volts when it passes through the second battery. It's a series circuit. There's only one path. So every coulomb of charge passes through both batteries. So in this case, the total voltage gained is just, again, the sum of each individual battery. So in this case, it's a total voltage gain of 3 volts. Okay, I gain 1.5 plus another 1.5, so I'm gaining a total of 3 volts. Okay, so that's connecting batteries in series. We can also connect batteries in parallel. This time, the batteries, the current that's coming through this circuit only passes through one battery at a time. So each coulomb of charge either goes through the battery on the right or it goes through the battery on the left. But it doesn't go through both. So again, if they're just 1.5 volt batteries, okay, we can also connect batteries in parallel. So again, if we have two 1.5 volt batteries connected together in parallel, the current that is flowing through this circuit doesn't pass through each battery. Each coulomb of charge either goes along this path, gains 1.5 volts, and then goes out into the circuit, travels around, gives up that 1.5 volts to this resistor and comes back, or it goes through this battery and gains 1.5 volts and then goes out into the circuit. So each coulomb of charge is only passing through either the left battery or the right battery and gaining energy through only one of the batteries. So in this case, the total voltage is just the voltage in one line or one path. So the total voltage here is 1.5 volts. Okay. So the current is only gaining 1.5 volts of battery because it's only voltage because it's only passing through one battery at a time. Okay, so that's resistors and batteries connected in series and parallel. And in the next video, we'll talk about something called Ohm's law, which is how we can relate all of these variables together: voltage, current, and resistance.